Recursion and financial modeling. Question 17. The graph above could represent the value of, and the answer to this question is option A, the balance of a savings account earning simple interest. And this is because the simple interest added to the balance of the account is an equal amount per year. Let's have a quick look at the other options. In option B, depreciation results in a decrease in value. In option C, the balance of a perpetuity is constant. In option D, the amount in the annuity decreases with the regular payments withdrawn. And in option E, the balance of the loan is constant as only the interest is paid. Question 18. The value of an investment in dollars after n years, Vn, can be modeled by the recurrence relation shown below. This investment earns compound interest at the rate of 5% per annum, compounding quarterly. The question is asking to calculate the value of capital R in this recurrence relation. We know that R equals 1 plus the interest rate per annum over 100 times n, where n is the number of compounding periods, in this case n equals 4. So this equals 1 plus 5 over 400, which is 1.0125. So the answer we are after is option C. Question 19. The value of a computer purchased for $5,000 is depreciated by 10% per annum using the reducing balance method. Recursive calculations can determine the value of the computer after n years, Vn. Which one of the following recursive calculations is not correct? We are going to start from V0 equals $5,000 because this is what the computer was purchased for. So option A is correct. V1 equals 90% of V0, which is 0.9 times 5,000. So option B is correct as well. Now V1 equals 4,500. So V2 equals 90% of V1, which is 0.9 times 4,500. So option C is correct as well. So V2 equals 4,050. Therefore, V3 equals 90% times V2, which is 0.9 times 4,050. This means that option D is not correct. Now, V3 equals 3,645. V4 equals 90% of V3, which is 0.9 times 3,645. So option A is correct as well. So the answer we're after is option D. Question 20. Leonard has invested an amount of money in a perpetuity. The perpetuity earns interest at the rate of 4.8% per annum. Interest is calculated and paid monthly. If Leonard receives $1,600 per month from the perpetuity, calculate the amount he has invested. To do this, we are going to divide 4.8 by 12 and by 100. By 12 because we want the interest rate per month. And this we multiply by the amount invested. And this equals the monthly payment, which is 1,600. Solving this equation, we end up with the amount that he has invested being $400,000. So the answer we are after is option D. Question 21. Durga invests $250,000 in an account that pays interest at the rate of 3% per annum, compounding monthly. He makes additional payments of $250 each month into his account. The value of Durga's account in dollars after n months, Vn, can be modeled by the recurrence relation shown below. The question is asking, by the end of which year did the balance of Durga's account first exceed $500,000? For this, we are going to use Finance Solver on available CARES technology. We enter 3 for the annual interest rate, negative $250,000 as the present value, because this is how much he invested. Payments per month, negative $250,000, and the future value, $500,000, with periods per year, 12. And then we can calculate the number of months, n, which is 215.86. If we divide this number by 12, that gives us the number of years, which is 17.99. So this is the 18th year. So by the end of the 18th year, the balance of Durga's account will first exceed $500,000. So the answer we're after is option B. Question 22. Cherie has purchased a boat for $90,000. She depreciates the value of her boat using the reducing balance method. For the first 2 years of reducing balance depreciation, the annual depreciation rate was 15%. Cherie then changed the annual depreciation rate to D%. After 3 more years of reducing balance depreciation, the value of the boat is $43,561.67. The question is asking for the new depreciation rate D. First, we need to calculate the value of the boat after the first 2 years. For this, we are first going to calculate the value of the boat after 2 years using the 15% annual depreciation rate. Notice the negative in front of the interest rate is because this is depreciation, which means that the value is decreasing. The future value after the 2 years is $65,025. Now we can calculate the interest rate D using $65,025 as the present value. So the new interest rate is approximately 12.5%. So the answer we are after is option C. Question 23. N has taken out a personal loan of $5,000. Interest for this loan compounds quarterly. N makes no repayments. After 1 year, she owes $5,325.14. The question is asking for the effective annual rate of interest for the first year of N's loan. First, we are going to calculate the annual interest rate. So we use 4 for N because there are 4 compounding periods in 1 year. 5,000 for the present value because this is N's loan. There are no quarterly payments, and we know that the future value is $5,325.14, and periods per year 4 again. We can now use this and calculate the effective annual rate of interest. On a TI Nspire, we use EFF, and we put the annual interest rate and the periods, and that gives us 6.5%. So the answer we are after is option C. Question 24. Vittorio has borrowed $40,000 to go on a holiday. Interest on this loan is charged at the rate of 8.3% per annum, compounding monthly. Vittorio intends to repay the loan over 4 years with 48 monthly repayments. After 47 equal repayments of $982.16, he finds that a small adjustment to the final repayment is required to fully repay the loan to the nearest cent. The question is asking to compare the final repayment to the 47 earlier repayments. First, we are going to calculate the future value after the 47 equal repayments. We can see that he is still owing $975.39 approximately. So this is going to become the present value for the last repayment. So this time we are going to calculate the payment required, and that is $982.1324 and so on. So the difference between the two is 982.16, take away 982.13, which is 0.03. So the final repayment is 0.03 lower than the other repayments. So the answer we are after is option B.